Time delay circuits are common in electronics, electrical, and automation circuits. A time delay circuit is a circuit that delays a signal from reaching its destination. Time delay relays, called timers, have many uses including general delay actions, sequential operations, and sensor delay responses. A typical relay consists of one or more contacts controlled by an electromagnetic coil. When the coil is energized, the normally open contacts close and the normally closed contacts open. When the coil is de-energized, the contacts return to their original position. A time delay relay is similar to a common relay in that a coil controls the contacts of the relay. However, a time delay relay includes a timing device that controls the power to the coil. An electronic device in the timer controls power to the coil of the relay. Two of the most common timers are on-delay timers and off-delay timers. The on-delay timer delays power to the coil until the time set point is reached. When the timer is energized, the internal clock starts and will not send power to the coil until the timer set point is reached. The coil will stay energized as long as the timer receives power. When the timer is de-energized, the internal timer resets back to zero. The delay will occur each time the timer is energized and will reset each time power is removed from the timer. The off-delay timer, when energized, immediately energizes the coil and changes the contacts. The delay occurs when power is removed from the timer. When the timer is de-energized, the coil remains energized until the set point time is reached. When the set point time is reached, the coil is de-energized and the internal clock resets to zero. Timers may be manufactured with a specific time delay set point. However, many timers can adjust the delay set point time using external settings. The timer shown here has a setting for milliseconds, seconds, and hours. The adjustment dial value will be a multiple of this time base. The timer shown here also has indicator lights to verify timer power and another to indicate time delay completion. Both off-delay and on-delay timers may have external controls for the time set point. Time delay relays vary in size, shape, and time adjustments. The ladder symbols for an on-delay timer are shown here. The timer coil is drawn like a typical coil. The symbols for a normally closed contact and a normally open contact indicate that the contacts are controlled by the delayed response of the timer coil. Timer coils and the contacts that they control are typically identified with the letter T or TR. The ladder symbols for an off-delay timer are shown here. The timer coil is drawn like a typical coil. The symbols for a normally closed contact and a normally open contact indicate that the contacts are controlled by the delayed response of the timer coil. Notice the difference between on-delay and off-delay contacts. Ladder diagrams are intended for circuit design and analysis of operation. Recognizing timer ladder symbols is important for circuit design, construction, and troubleshooting. Understanding the delayed response of both on-delay and off-delay timers is important. The official ladder symbols for on-delay contacts and off-delay contacts are rarely used. The ladder symbols for both on-delay and off-delay contacts are drawn as typical normally open and normally closed relay contacts. The contacts are identified by the timer coil. It is important to note that most timers are on-delay timers. It is safe to assume that any timer that is used is an on-delay timer. The two most common types of time delay relays are off-delay timers and on-delay timers. There are many uses for timers in electrical and automation systems. Understanding timer operation is essential for circuit design, circuit construction, and circuit troubleshooting.